chat, make sure you let me know if you can hear me, because I've just gone off mute. So, no, you can hear me on the phone, but I'm talking about through the live stream, which there'll be a 40-second delay. So, okay. Okay, well, I'm going to flip over to here, and then we will start this. Hi, everyone. It seems that you've tuned into our Meltric live stream. If you're seeing me on the screen, you will have been in a mode where we're doing a live stream. We are here live in my office to discuss today what is the when you should use a switch rated plug and why you might want to use a switch rated plug over a pin and sleeve device. So that's the topic. If you intended on hearing that, you are in the right place for it. So to begin with, I think we need to talk a little bit about plugs and receptacles in general. Right now, there's really about 3 different types of plugs and receptacles out there. There are twist locks, there are pin and sleeves, and then there's this other type of device known as a switch-rated plug and receptacle. So what makes a switch-rated plug and receptacle? I think we can't really have a discussion about plugs and receptacles and the differences between them without knowing what makes a switch-rated plug and receptacle. So here's an example of Meltric's version of a switch-rated plug and receptacle. It's a DSN 20 amp, 120 volts. And what makes it a switch-rated plug is it has a switch integrated into the device. So when I press this button up here, I am able to separate the plug and receptacle while it's energized. I'm also able to make the plug and receptacle while it's energized. And that integrated switch function turns this, what would normally be considered a standard plug and receptacle or a pin and sleeve device, into a switch rated plug and receptacle. So we're approved for operation as a switch. We comply with some of the details in National Electric Code as a switch. So I'm going to show you some of the things that we do in our device that actually make us a switch. So I'm going to transition over to this. And what you'll see here are some of the key pieces of a Meltric device that allow us to meet the requirements of a Meltric or of a Article 404 switch. So a couple of those things are we are able to have the grounded conductor make and break, or make first and break last. We have the enclosed push button capability, so that's what that button is there for. When the plug is removed from the receptacle, you can see that we have a off indicator on it, or maybe you can see it. It's a little difficult to do it with the background. So all of these requirements in NEC that you need to meet in order to be a switch, our device has been able to meet those requirements, giving us the ability to be a Article 404 switch in UL or in NEC, and actually allows us to meet UL requirements for a switch. So that kind of is the difference between a switch rated device and, say, a standard plug and receptacle. One of the questions then comes is, now that you've got this sort of switch rated plug and receptacle, why is that important? And I think a lot of that has to do with the fact that in the National Electric Code, there are lots of different references to this thing called a disconnecting means. And most people that I've talked to when out in industry refer to a disconnecting means as sometimes a disconnect. And then therefore they also get into this other area known as a disconnect switch. But for the purposes of this presentation, we're going to be focusing on just disconnecting means. Why do I want to do that? Because in all of these different applications in the National Electric Code, you have disconnecting means listed out. So for example, maybe we'll be talking about welders in a minute. So in the welders section of the National Electric Code, they will reference disconnecting means, and they will put some critical features of what is required of the disconnecting means for that application. So when I went through the National Electric Code and looked at all of the devices that are, all of the applications that refer to a disconnecting means, I was able to find a couple of places that reference some of the key things that are required of a disconnecting means. So I'll show you that slide real quickly. Bear with me for a second while I pull this up. So in the disconnecting means sections, when I'm looking through all of the different articles or all the different applications that refer to a disconnecting means, I was able to pull out a couple of key things that are required of the disconnecting means. So anywhere where there's a application that requires a disconnecting means, we just go to Article 100, which is the definition of a disconnecting means. Then you'll see some applications refer to the disconnecting means needs to be switch rated. So when that happens, you can use things like, sometimes you can use molded case circuit breakers, sometimes you can use a standard disconnect switch, and you can also use a Meltrick device because it is approved for a switch. Sometimes a disconnecting means can be a plug-in receptacle, and oftentimes you'll find that there is no further requirement in the application than being a plug-in receptacle. The rest of these things are all like being rated for the amperage, being rated for the horsepower, within line of sight. We see a lot of this lockable disconnecting means as well, so I'll talk about some of the things that our device does in that area that can help you meet the requirements for a disconnecting means. But primarily, when we're talking about applications, what we want to be looking for is, does your disconnecting means require it to be a switch? Because if that is the case, for example, we'll go to welding machines, because that's one of my favorite applications. I will see things that say, all right, in the application Article 630 for electric welders, it defines that the disconnect switch or the disconnecting means must be a switch or a molded case circuit breaker. So in that particular application, if you are using a plug-in receptacle as the disconnecting means, the disconnecting means must be switch rated. So that is a requirement of the National Electric Code. That makes this device a perfect disconnecting means for electric welders, because it's not only a plug-in receptacle, and electric welders like to move around shops, but it's also a switch. So you can comply with National Electric Code for a disconnecting means. Maybe another one might be like electrified truck spaces as well, where we have a requirement of the disconnecting means being a switch as well. In addition, it has to be readily accessible and lockable. So those are kind of the requirements that I was able to find in the National Electric Code around disconnecting means. And I've gone through, pretty much the whole National Electric Code and looked at all of these different occupancies and applications and tried to figure out what's required of the disconnecting means. So I don't want to go through every single one of them, but if you do have a question about a specific application or occupancy, you can go ahead and go to the chat in the what do they call that? The booth, the virtual booth, and you can make a comment there. And I've got a friend on the line in my ear right now that will tell me that somebody is trying to ask a question, and I'll do my best to answer that question on the live stream. So those are kind of the areas where you have an application for a disconnecting means and some of the additional things that are required of that disconnecting means. You can use a plug-in receptacle in several applications as the disconnecting means. There are certainly areas inside of the National Electric Code that specifically call out you can use your plug-in receptacle as your disconnecting means. So you don't always need a switch-rated plug-in receptacle. And I think a lot of people will use that disconnecting means, just regular plug-in receptacle, as the disconnecting means. But I will caution on this, that if you are going to use a plug-in receptacle as your disconnecting means, you do need to look at some of the other requirements of the disconnecting means and make sure your plug-in receptacle will meet those requirements. So specifically, one of those that I talked about was having a lockable disconnecting means. And in our device, we actually are able to do a little lockout tagout hole on the inlet. And then what you can do there is put your lock through the lockout tagout hole. You can then no longer energize the plug in the receptacle because that lock is blocking the operation. And that makes it a lockable disconnecting means, which is as defined by the National Electric Code. So when we're talking about National Electric Code, we're always looking at places to utilize these plugs and receptacles for the convenience sake of it being maybe close by to the device that you're wanting to do maintenance on. Suppose it's a motor and you want to go ahead and do your disconnecting means right there at the motor, lock it out, tag it out, follow all your electrical safe working procedures, and then be able to do whatever you need with the motor and then put it back into service by plugging it back in. So that makes it a lot more efficient. It keeps you in compliance with things like line of sight disconnects. It keeps you in compliance with lockable, and it can really help you make your lockout tagout procedures a lot more efficient. So that's kind of where we would see a little bit about the we would see a little bit about where to use plugs and receptacles. And I've just been being told that I've got a question from Christopher, which so the question is that what would happen if you have a locked rotor or something like that around a motor? And if you were to have this condition where, say, the motor is shorted or maybe locked up, and you try to close on that fault condition with your plug-in receptacle. So it's a really interesting question and something that's super important in safety, because if you do close on a fault, you may potentially cause more current through that device than what the device is rated for or tested to, and the device could fail catastrophically. So with a Meltrick device, we have some additional requirements that we need to meet in order to have our horsepower ratings on our devices, in order to be able to do that closing on a fault. And it's a particular term that is in the plug and receptacle world called short circuit make it withstand. And what the test is basically we fault one end of the plug and we go and close on that fault. And what we're looking for is what is the amperage that we can have through the plug and receptacle without a catastrophic failure for an amount of time. So in those instances where we have the ratings on the plugs, these short circuit make and withstand ratings, also sometimes referred to as AIC ratings, our devices depend a lot on what is upstream of the Meltrick device. What is the protective, overcurrent protected device that's upstream of that? If it is fast acting, like say a type J fuse, we're able to see 65,000 amps through our device while that device trips. We're also able to, in some of our other devices, see up to 100,000 amps. before that device trips. Now, having type J fuses or class J fuses before your plug-in receptacle isn't the most common thing to do. There's a lot of people that will use circuit breakers above your plug-in receptacle for their overcurrent protected device. And when we're doing that, there's a standard overcurrent protection of closing on the fault of 10,000 amps. So all of our devices that are being protected by circuit breakers have 10,000 amps overcurrent protection device. So I hope that answered the question about how you can close on a fault and whether or not the device stands together. So on motors also, there's another additional thing that's very important in selecting a plug-in receptacle, which is to ensure that your plug-in receptacle has a horsepower rating, because there's an additional test to make sure that we can do 50 operations while that plug is seeing 6 times the FLA of the motor, which is the locked rotor condition. So our devices that have horsepower ratings may look overspecified from an amperage perspective, but you've got to remember that we're having to do that make and break as in a locked rotor condition. So that could be up to 6 times the rated FLA of the motor. Now, you don't have to do an FLA. From my experience of reading through the National Electric Code, you don't have to do a horsepower rated plug-in receptacle. There are abilities to be able to do non-horsepower rated plugs and receptacles, but you still have to meet the amperage requirements for locked rotor condition, because there is the opportunity for that plug-in receptacle to have more current through it than what the plug-in receptacle is rated for. So you want to make sure that you can handle those fault conditions. So the 2 ways that we do that in motors is making sure that you have a horsepower rated device, and then for your short circuit make and withstand while the overcurrent protective device is tripping, you want to make sure that you're coordinated with your fault current, available fault current through the device. So we want to be at either 65,000 amps, depending on the type of overcurrent protection, 100,000 amps, or maybe even 10,000 amps if it's a circuit breaker. So hopefully that answers that question, and I appreciate the question. It's nice to have a little interaction with the group in this live stream. So thanks, Chris. We appreciate that. Or Christopher. I don't know if you like to go by Christopher. Appreciate that. So kind of before we go into sort of the next portion of this presentation, I really just wanted everybody to know to pay attention in the National Electric Code when you're specifying your disconnecting means, particularly if you're going to use a plug-in receptacle for that disconnecting means, because you've got other additional requirements of the disconnecting means that your plug-in receptacle may not meet. So ensure that when you specify that device for a disconnecting means, you include other things that are required. Maybe it's switching, maybe it's accessible, maybe it is the ability to be lockable. So if those are the things you're looking for, just make sure that your plug-in receptacle, if you're using it as a disconnecting means, has those additional features as well. By the way, Meltrick has all of those features. So let's go on to something else here. Ooh, I was standing up that whole time and you guys were not seeing me. Live streaming for the first time. Oh, and now I'm going to sit down. So let's go back to one other thing real quick, where we're going to talk about now, because we've gone through where you might use a switch-rated plug-in receptacle. Let's talk a little bit about why you might want to use a switch-rated plug-in receptacle. So obviously, when you have a plug-in receptacle that is going to be connected or disconnected while it is energized, you are probably going to want to have that device be switch-rated, particularly if the intended purpose of that device is to be the switch. You will want it to be switch-rated. So if you've got plugs and receptacles and you're not going upstream and verifying that you're de-energized and following all your electrical safe work procedures while doing that, and you're using the plug-in receptacle to make and break a load, you are actually violating the requirements that your manufacturer is telling you. So when you get your plug-in receptacle, you're going to have some things that are going to be listed for what your device can do. This is true for all equipment. So the device can be a plug-in receptacle. In our case, the device can be a switch. And some of these plugs and receptacles also have this other rating known as a current interrupting rating. So what that is that's the ability to interrupt current while the plug is energized, accidentally interrupting the current. You can ensure that for a certain number of times, that device will not fail. That creates a problem when you're making on that plug because the device is not rated for that. So you should make sure that all of the upstream safety checks on zero energy conditions when you're not using a switch rated plug and receptacle are met, so you're not making and breaking on that plug and receptacle. So that's one thing that you need to pay attention to, is that the device has a set of things that it's able to do that the manufacturer will tell you that these devices are able to do. And you need to make sure that you're following the manufacturer's listed applications, recommendations, or how to use the product. So with our Meltrick devices, we are a switch. We allow you to make the product under load and break the product under load. And we have to go through some specific tests with UL in order to be able to tell you that that is something that we allow. And in a Meltrick device, it's like 6,000 operations under our rated voltage and current that we're making and breaking these devices. So we have to do a pretty stringent test in order to allow our users to be able to make and break a plug and receptacle while it's energized. So that is the first step of this, why you would want to use it, is if you have people that are making and breaking plugs under load, make sure that your device is rated for that application. It is a requirement, I think, in NFPA 70 and NEC that you utilize your equipment per the manufacturer's recommendations. So keep that in mind. If you're using a plug and receptacle like this twist lock or something like that, and you're breaking it under load, the manufacturer has not told you that you can do that. So if anything were to happen, they could come back and say, well, you're using that device not per the manufacturer's recommendations, and it could be your fault for any of the problems that occur from that. So because we're at the Electrical Safe Work Guide, I want to talk one more thing about why you might want to use a plug and receptacle that's switch rated, and that is that when you have an exposed conductor, let's move to that slide real quick. So whenever you have a exposed conductor, you will have a associated limited approach boundary, or I think it's limited approach boundary is what we talk about these days, where you will need to make sure that only qualified people are within that restricted boundary or restricted space. With a pin and sleeve device, you will have an exposed conductor, and all conductors that are exposed that have not been verified de-energized will have this restricted space around it. So in the most stringent reading of the NFPA 70E, if I remove my plug from my receptacle and I'm using a pin and sleeve device, I will have exposed electrical conductors. Therefore, I will have a restricted space around that where only qualified people with their appropriate PPE who are understand the hazards of working around this exposed conductor are able to work in that environment. So one of the really neat features about a Meltrick device is we have, when you remove the plug, we have a dead front shutter that closes all of the live conductors from anybody accessing them. So when it's in an enclosed space, we have no exposed electrical conductors, and therefore we have no restricted approach boundary, limited approach boundary, however you want to say it. So when, okay, I hear that we have a question. I will go interrupt that real quick to answer this question. So read the question to me, and I will do my best to answer it. We're going to go back up to the standing part and see if we can answer that question. So what's the question? Okay, so the question was, With a switch rated plug-in receptacle, we have the 6,000 make and breaks we have to make. What's the requirement for something that's being rated as a current interrupting device? So there's two other tests. There's current interrupting, and then there's non-current interrupting devices. So with a current interrupting device, there's no test required to do a energized disconnect for that, because it's not a current interrupting device. So you don't have to do that test. For these other devices that are referred to as current interrupting device, it depends solely on the current that is being rated for. So, for example, if you have a 20 amp plug-in receptacle, those have a testing for current interrupting of 5,000 operations. And I know what you're thinking, okay, 5,000, 6,000, what's the difference? There's not much, but when you get up into, say, the 250 amps or 200 amp area for a switch rated plug-in receptacle, we still have to meet that 6,000 operations under load, where a current interrupting device has to do, if I'm not mistaken, I believe 50. I might have to look that back up, but it is very, very minimal. It might be 500. So in other words, the figure I do remember right now is we have to do in that area 24 times more make and breaks than a current interrupting device in that same type environment. So I like to put this in terms where a lot of people can think about it on a day-to-day basis. So if we're talking about 6,000 operations making and breaking under load, and we're looking at doing that 3 times a day, and we have, let's say, 1,000 days 365 days in a year, times 3 times a year. Let's just say, rounding up, we're going to have about 1,000 breaks per year. So if we have to test for 6,000 operations, we basically get 6 years of 3 make and breaks a day with some vacation days of operation that you're guaranteed with using a switch rated device. So, being a manufacturer, we like to hedge our bets a little bit on that. We actually warrant our electrical contacts for 5 years of operations, because in our experience, it is very rare to find anybody who actually does make and breaks 3 times a day, 365 days a year. So to make a long story short, when we get into the lower amperages, those numbers are much more in parity with each other. We're still doing more make and breaks, but as you get into higher amperage devices, we start to diverge a little bit, and our requirements to be a switch require a lot more electrical endurance testing than something that's just current interrupting. So I hope that answers your question, and appreciate the question. Again, during a live stream, it's always nice to have interaction, and I certainly appreciate the fact that you guys are interacting with me. It makes it much more fun to be up here, and almost like being in a booth. I can answer these questions to people as they're coming by. So thanks again, appreciate that. Okay, got another question. So keep them coming. I like it. I can, yeah. So the question is, when we have our device, which is a switch and a plug-in receptacle in the same device, we're a switch-rated plug-in receptacle. But there are other devices out there that are both a switch and a plug-in receptacle. So it's not the integrated switch and plug-in receptacle together. It is a switch with a receptacle on the bottom of it. And what they'll do, because they want to also follow the rules around not being able to separate that plug or make that plug while it's energized, they'll interlock the switch with the receptacle or the plug. So that's one way to say, okay, when the plug is inserted and my power is on, I've now got this lock that holds my plug in place. And no matter what I do while that power is on, I can't remove that plug. Then I can turn the power off to the off position and be able to remove that plug. So it sounds like, yeah, we're doing everything right. We've got, from a code perspective, we've got our switch, we've got our plug and receptacle. But when we start bringing in NFPA 70E to the question, it's a whole nother story. Because we now have to start saying that we're going to do this action of turning off the switch, But because we're going to have an electrical function after we do that, we need to do verification that those conductors are going to be de-energized. And the only way to do that in a rotary or disconnect switch, mechanically interlocked disconnect switch, is to open the door and visually verify that the blades have separated. Once you do that, you're exposed to electrical conductors. You have to be a qualified person. You have to have the appropriately rated PPE. You have to know what you're doing and be safe doing it, just to verify that those blades are separated. The other potential way is we turn off the switch and then we remove the plug and then do our verification through a contact measurement. At that point in time, when you're doing a contact measurement, you're exposed to unverified conductors. You need to be a qualified person, and you need to have the appropriate PPE, and you need to follow your safety procedures. So the big difference between that, which is code compliant, it's a switch and a plug and receptacle. You're going to use your plug and receptacle where it's never having that make and break that's happening while it's energized, or connecting while it's energized, or disconnecting while it's energized. You'll have that ability to do that thing, so it's code compliant. But from an NFPA perspective, it becomes very difficult and requires an extra level of qualified person in order to be able to operate that device. With a Meltrick device, we still have the switch, we still have the plug and receptacle. So from a code perspective, we're pretty similar, but our operational side of breaking that plug and receptacle and doing a verification that we're de-energized happens by simply removing the plug. So our contacts are able to make and break under that load, so we're okay there. As the manufacturer, we're telling you, you can do that with these devices. Then when you remove the plug, you're getting a visual verification that your plug, whatever was connected to that plug, is now de-energized. You have an air gap that's happening between the plug and the receptacle. When you've removed that plug, you've also closed this dead front shutter. So you're seeing this air gap and you're never being exposed to any energized conductors. So that's the cool trick with Meltrick, is that dead front shutter closing off those energized conductors means you can actually visually verify that there's this air gap being created between your supply and your load, and you're never exposed to electrical conductors while doing that operation. So I'm doing my verification, I'm applying my lock, I know everything downstream of my device where I've unplugged that is de-energized. I can go about doing whatever I need to do. Maybe I'm a mechanical guy who doesn't have electrical training. Since I'm not being exposed to electrical conductors, I then can go ahead and do what I need to do and then plug that plug back in, because I'm never being exposed to any electrical conductors. And that's the trigger for a qualified electrical person, is when you have an exposure to an electrical hazard like shock or arc flash. Only way that happens is when you have exposure to an open conductor. So I hope that answers the question about the differences between a mechanically interlocked disconnect switch and a Meltrick device, which is, for all intents and purposes, a mechanically interlocked disconnect switch, because you cannot remove the plug without first turning off power. So we actually fit that definition as well. So I hope that answers the question. And again, very much appreciate having a little bit of this interaction. It's really fun for me to hear some of the questions that are going on out there. I really appreciate the feedback. So let's go back a little bit to that presentation, and we'll talk a little bit more about that dead front shutter side of things. This is where it's super important in regards to having a dead front shutter, because when you remove a plug from an energized receptacle, you will have exposure to conductors. When you are exposed to a conductor that has not been verified zero energy or de-energized, then you have this limited approach boundary, and that triggers all of those electrical safe work procedures that you have in place through NFPA 70E. You have to get a qualified person to do that. You have to have the appropriately rated PPE for whatever your exposure is to arc flash. You have to potentially have PPE for shock exposure as well, for electrical shock. So when you have those pin and sleeve types devices, make sure you're aware of this. I'm not saying you can't use a pin and sleeve device. I'm just saying that what you have to do is you have to be aware of what the safety community, what the safety standards are telling you you should do when you're utilizing these types of devices. There are pin and sleeve devices all over the place in the field. I just see, in my experience, a lot of people using them improperly. So we have one other question, and I will let's go back to me standing up and see if I can't answer that question. Here we go, standing up. What's the question? So the question is, what if we were going to try and address the arc flash hazard with a competitor's plug? So I try to stay up to date on our competitors that are out there. And so there's a couple other competitors that maybe we're talking about with the switch rated side of things. And if we're talking about that, there are some things that I would address with a couple of products. But if we're going to try and stick with, say, this difference between switch rated and pin and sleeve plugs and receptacles, then I would say that from a competitive perspective about switch rated versus pin and sleeve is pin and sleeve products expose you to shock and arc flash hazards when you remove the plug. So when they're together, when they are, as long as they're de-energized, if they're apart and de-energized, or if they're together, then there's no exposure to any of these live or potentially live conductors. And therefore, when you have no exposure, you have no arc flash potential. When you remove the plug, though, now you have exposure to live conductors that somebody can touch or maybe even short one of the conductors. And if that were to ever happen, that's where you start to get into your arc flash potential. So if we short a phase to phase or phase to ground, we could get an arc flash there. When we have a Meltrick plug and receptacle, you have this dead front shutter that happens, and therefore there's no ability to get in and do any of that shorting. So this dead front shutter here is the key trick into, I won't say trick, but it's the key feature of a Meltrick device that eliminates that arc flash hazard, because there's no way for you to be able to short in an exposed receptacle, no way to short one pin to another pin. So you can't go phase to phase, you can't go phase to ground, you can't short the devices, and therefore you can't have an arc flash. So with that said, the other area that we discussed a little earlier is this closing on a fault. So if you have, say, a short in the cable below the plug and you go to close on the short on a shorted cable, so we're looking at where's the arc flash potential there from doing a closure on a fault. And I think if that's where the question is taking you, you need to start looking at what your potential energies are, potential fault currents are for the device, and make sure that your device is rated for that particular fault current. So as I described before, Meltrick devices, when having a circuit breaker, have a 10,000 amp short circuit make and withstand rating. And then if you start doing some better fusing above the device, you can get into 65,000, 100,000 short circuit rated plugs and receptacles. So that's the coordination between your overcurrent protection device and your plug and receptacle, being able to make sure that the device itself can handle closing on a fault, because you will have some potential arc flash capability. One of the things that's interesting about some of the operations, this is a really interesting thing in my opinion about the difference between a pin and sleeve and a Meltrick plug and receptacle, is when we go together, you actually have to do a short little rotation in order to open that open and close that shutter. So we rotate from about the 10 o'clock position to the 12 o'clock position, and that opens the dead front shutter and aligns our contacts. We then close on those contacts. So it's kind of interesting though, because if we were to close on a fault and create an arcing event that happens in there, this plug has the potential to kind of blow out from the receptacle, because we're going to create an explosive event that happens inside of there. That opening and closing of the dead front shutter is also engaging these little ears on our inlet. So when it's in there, if we are to close on the fault, it will just pop open and still stay closed. So Any arcing that's happening in there is staying contained within the plug. The plug is not ejecting from the device. And that's a unique feature to Meltrick in that when you do that, you're actually still able to contain all of those things. In a pin and sleeve that operates on a straight insertion kind of method, if you do have that kind of explosion that happens from closing on a fault, you risk having that plug shoot back out at the user, and then any arcing that happens comes out as well. So it's kind of an interesting thing we don't talk very much about, but that capture of closing on a fault and containing that arc is also something that's pretty unique to a Meltrick device. That's why I like talking to everybody at the ESW, because you guys always come up with some really interesting questions and help me to remember some of the interesting features about Meltrick that I don't get to talk too much about, because a lot of people just assume or think that it's just a plug-in receptacle and they just want a more reliable, more durable plug-in receptacle. And we're good at that. But these interesting conversations around the electrical safety about it are really fun for me. So I appreciate that question. Thanks for giving me the opportunity to talk about that capture of the device if you are to close on a fault. So really fun for me. Let's go back to the presentation until we get to another question. So let's see. Back in the presentation, we will go ahead and look at, I'll probably do this for about 5 more minutes, I guess, and then maybe I'll look at the chats and see if we can't answer a couple questions real quickly on the chat that way. So I do want to just reiterate this fact that when you remove a plug from the receptacle on a pin and sleeve, you will have exposure to conductors. And it's that exposure to conductors, particularly ones that we haven't verified zero energy on, where we have this limited approach and are required to have a qualified person or a person who knows what they're doing with the appropriately rated PPE do that operation, do their work in those types of environments. So I can tell you that this is one of those things that I see all the time in the field, which is a receptacle on the wall. Maybe it's on a disconnect, maybe not. And maybe the disconnect's in the off position, but the lid is off of the pin and sleeve device. So you still have exposed conductors, and perhaps you don't have the lock in the off position. So you have exposed conductors with the potential for having those conductors be energized, and therefore operating inside of that space is considered working, and you have to be a qualified person to do work in a limited approach boundary. So I think that's a really unique and interesting feature about Meltrick, and one of those big differences between a Meltrick device or a switch-rated device and a pin and sleeve device is this ability to, when the plug has been removed, to make sure that you're never going to be exposed to potentially live conductors. So that's kind of, let's go back to I'm going to go switch over to this view. So let's go back to why we're here in the first place. So you came to the live stream because you were interested in knowing when you should use switch-rated plugs and why you should use them. So let's see if I've answered that question. So when should you use them? I think you can use them, specifically you should use them, or I think if we want to use a code side, you shall use them whenever you want to use your plug-in receptacle as a disconnecting means, and that disconnecting means is required to be a switch. So you can have other disconnecting means. Maybe you want to have a molded case circuit breaker be your disconnecting means upstream. That's code compliant. So you're allowed to do that from a code side. But the question then becomes is, how are you using that disconnecting means? If you are going back, say you're in a welding facility, and you're going back to the circuit breaker every time you want to unplug your welder, and you're shutting off the circuit breaker, then you're using that as the disconnecting means. NFPA 70E says, well, now we've got to verify that we have no power. And the only way to do that is to do a contact measurement, probably at the plug-in receptacle. And the only way to do that is with a qualified person who has the appropriately rated PPE and understands the hazards So then he throws the breaker, walks all the way back, and then unplugs it and tests for 0 voltage, says we're good, locks out, tags out, or his lock's already on there, we're all set, go ahead and do what you need to do. So if you want to have a welder operate a disconnecting means, because the disconnecting means for electric welders has to be a switch or switch rated, the way to do that is to have your plugs be switch rated plugs and receptacles, because the operator is going to use the plug as the disconnecting means, and the requirement is that the disconnecting means be a switch. So you can use plugs and receptacles in that environment as long as they're switch rated for the disconnecting means. Now there are other things like appliances, which will say, you know, you have to have a switch, but you can also use a plug and receptacle. In my mind, I like to think, why not get the best of all the worlds? So I'm going to use a plug and receptacle for the convenience of it being located close by to where I need it. For all of those convenient features around a portable piece of equipment, I'm going to use that plug and receptacle. But it also, if it were not using plug and receptacle, would need to be a switch. So why wouldn't I have a plug and receptacle that's switch rated in that type of environment? Because now I've got both. I'm covering both the spectrums. It's a plug and receptacle, so yes, it's compliant. But if it weren't a plug and receptacle, it should have been a switch. And so by using a plug and receptacle, I'm on both ends of that. So whenever you're looking at where to use it, I think you need to go review your disconnecting means if you're going to use your plug and receptacle as the disconnecting means. I would say in general, to be more safe and on the safe side, we're at a safety presentation, I think it's an excellent idea where if you are going to use a plug and receptacle as your disconnecting means, why not have it be a switch? Because having a switch rated device takes into account all of these other efficiency things that you have to do if you're going to use a plug and receptacle. You have to verify that you're zero energy. You're not making and breaking a plug and receptacle on load. You have to be concerned that when a plug is removed from a pin and sleeve plug and receptacle, you have exposure. All of those things are required with a pin and sleeve that when you have a switch rated device are not required. You can actually feel perfectly safe going up to a switch rated plug and receptacle and making and breaking that thing under load. So I mean, obviously I sell these for a living. It's my job to tell everybody, use them wherever you can. But in my mind, just having read the code and understanding what I know about NFPA 70E, I look at a switch rated plug as sort of the way to catch all of the things and eliminate those hazards around using plugs and receptacles. So in my mind, I would say, where do you use a plug and receptacle? You use it, or where do you use a switch rated plug and receptacle? Use it anywhere that you're actually using a pin and sleeve, because I have seen too many times where people are using pin and sleeves not according to the manufacturer's recommendations, not having somebody who's electrically qualified operate that unit. Those are all the things where if anything were to happen while somebody is making and breaking a pin and sleeve, I think you're opening yourself up to liability. So switch rating plugs and receptacles gets you through all of those things that we're talking about. Why? Because we have contacts that are capable of breaking under load and making under load. We have the appropriate short circuit ratings to close on a fault. We have dead front shuttering. All of those things are the why as to why we're the safer option in that environment. So I think with that said, I'm really surprised I was able to fill up 45 minutes and couldn't have done it without your guys' help. Appreciate the questions. I think I'll be on for another 15 minutes if we have any other questions. Otherwise, you're going to get to stare at me in my live stream sitting in front of my office in Franklin, Wisconsin, where all of Meltric's devices are put together. We are basically assembling these things per the order. So if you have a certain number of contacts or a certain voltage that you want, we have the capability of building those things in Franklin, Wisconsin, putting them in a box and getting them to you in about 2 days delivery time. So I'm very impressed with Meltric's capability to get our customers what they need when they need it, because in my opinion, most people are thinking about plugs and receptacles much later than maybe when they should. So it's kind of an afterthought when the contractors are going in to put things in. Oh yeah, we're supposed to get a plug and receptacle there. And I've just seen a lot of times when people need that and they want it tomorrow, and Meltric has that ability to get you what you need tomorrow if you want it. So That's one of the reasons why I put me in front of our office space. All right, so I'll go look at this chat here and see. We've had Luis and Keith helping us out in the booth, and so they've hopefully been answering some of those questions that I haven't been able to get to. I've got this little earpiece here. It feels like I'm actually in a studio, even though I'm in my office. I've got this earpiece that Keith has been talking to me about. Keith is our regional sales manager for the East. He can help anybody that's up in that northeast corner there. Sorry, what's that, Keith? You were saying something? Props. Oh, props. So yeah, thanks so much for everybody being in the live stream. It was kind of an interesting experience. We will hopefully have the opportunity to meet in person at the next IEEE. I think everybody's really excited to get back out there and say hello to some of their friends. I know I've been doing this for a little while. I miss saying hi to everybody at the show. So thanks for coming to the live stream. And if you have any further questions, I believe we have our contact information in our booth there. We also will be more than happy if you guys want to chat with us on the attendees. There's a list of the people who are all here participating in the booth at the bottom. You can always go to the attendees and pull up a direct chat with them. They're happy to answer any questions that you might have there. So with that said, I believe that I should be done and you guys might be getting ready for your very next session. So thanks again for attending the live stream and really appreciate the questions. If you need any help, we're here to help. So signing off from Meltrick. Thanks, guys.